Hello students, so what's up? I hope all of you are doing well with your studies and life. Today's video is a special video. This video is going to be on a special type of reaction, a named reaction rather, known as Friedel-Crafts reaction. A very important reaction for the students of standard 11, 12 and those who are going to appear in the competitive exams like NEET and JEE. But before starting the video, I would expect my students to sit with a notebook and pen and continue watching this video without skipping in between and watch till the end. So let's start. So our topic is Friedel-Crafts reaction. In short, we can write FCR. So, as soon as I write Friedel-Crafts reaction, the question that comes to one's mind is, what is it? You know, these are a set of reactions developed by Charles Friedel. These were actually the scientists. They were the scientists, Friedel and Kraft, and James Kraft in 1877. Just look at the time. Okay, way back in 1877 to attach, and this reaction has relevance even today. Attach substituents to an aromatic ring. Okay, suppose, so again I would repeat, what is a Friedel-Crafts reaction? These are a set of reactions developed by, you can see the name of the scientist, Charles Friedel and James Kraft, and it was developed in 1877 to attach substituents to an aromatic ring. You know, aromatic ring means benzene ring. So if you want to attach substituent here, okay, or something like this. Okay, so these are the substituents. If you want to attach a substituent like this on the benzene ring, it was possible because of the effort due Friedel and Crafts. A lot of thanks to them. Now the next thing is, then you know, this, as I have already written here, so that these are a set of reaction. Actually there are basically two types of Friedel-Crafts reaction. I'm writing FCR in short. First, Friedel-Crafts alkylation, and second, Friedel-Crafts acylation. Okay, so these are the two types of Friedel-Crafts reaction, Friedel-Crafts alkylation and Friedel-Crafts acylation. And one thing, if we want to think about the mechanistic pathway, then both proceed through electrophilic aromatic substitution reaction. Okay, so this is the reaction mechanism. They follow electrophilic aromatic substitution reaction. We will learn about the mechanistic ways in the second part. This is part 1 of Friedel-Crafts reaction, please remember. Now one more thing, so what is the use? Use is that by Friedel-Crafts reaction we can, or to generate, to produce alkylated, monoalkylated or acylated arenes. It is the general purpose of this reaction, or the general use of this reaction, is to generate monoalkylated or acylated arenes. So I would again recapitulate Friedel-Crafts reaction. These are a set of reactions developed by Friedel and Crafts in 1877. What was the purpose? The purpose was to attach substituent, to attach some groups on the aromatic ring, that is the benzene ring. And obviously there must be some ways by which we can do this. We will come to learn about this later. And there are two types. One is the Friedel-Crafts acylation and another is Friedel-Crafts acylation. So, and both of them, both Friedel-Crafts acylation as well as alkylation, both follow electrophilic aromatic substitution reaction. So let's know part wise what is Friedel-Crafts alkylation and then Friedel-Crafts acylation. You can note it down. So now we will learn Friedel-Crafts alkylation reaction in detail. So as you have already learned that by Friedel-Crafts reaction, what do? We attach certain groups to the benzene ring or the arene. So this is a benzene ring. Now when it is treated with a haloalkane or rather chloroalkane in presence of a catalyst anhydrous AlCl3, then what happens? This substituent, this gets attached here. This is the root reaction. See here, as I have already told, through Friedel-Crafts reaction we are capable of attaching some substituent on the benzene ring, on the arene. So how we have done that? We have taken here chloroalkane. So in presence of chloroalkane, what happens? This alkyl group has got attached in this benzene ring. So because an alkyl group, this is an alkyl group, because an alkyl group has been attached in the benzene ring, on the benzene ring, so this is called Friedel-Crafts alkylation reaction, because an alkyl group has been attached. So that's the reason why it is called alkylation. Now you can see here we have anhydrous AlCl3. So what is the function of this anhydrous AlCl3? You know, to understand this, first of all, if you draw the structure of AlCl3, see here, 1Cl, 1Cl, 1Cl. So see here, there are 6 electrons around this aluminium. This aluminium, that the atom of aluminium has 6 electrons around it. So this aluminium is electron deficient. So because it is electron deficient, so it acts as Lewis acid. What are Lewis acids? Lewis acids are electron pair acceptors. Please remember. So what aluminium would want? It would want to get octet configuration. Around aluminium there are 6 electrons, but for stability you know that an atom should have 8 electrons around it. So to get stability, what this aluminium does, it, you know, abstracts this chlorine molecule and in the reaction generates, so this AlCl3 abstracts Cl from RCl and generates electrophile. It helps in the generation of electrophile R plus. Okay, so the purpose of AlCl3 is to help in the generation of an electrophile. And why? How does it do so? It does so by abstracting the chlorine atom, which is bonded to the chloroalkane. By abstracting it, it takes the chlorine molecule and it becomes stable by getting octet around it, and in the way it generates an electrophile, which is necessary for the reaction, for the reaction to occur further. So that's its purpose. Now one important fact here is that AlCl3 must be anhydrous. If we take hydrated AlCl3, then what will happen? It will result in it will create what, Bronsted-Lewis system, and this will result in isomerization of Friedel-Crafts reaction. So our purpose of forming alkyl or acyl group, or rather attaching on a benzene ring, will not be satisfied. So that's why we should not use hydrated AlCl3. We are always required to use anhydrous AlCl3. By the use of anhydrous AlCl3, we will be able to generate the electrophile necessary to carry out the reaction further. So now let us see some examples of Friedel-Crafts alkylation reaction. I hope you have understood this. So what we came to know in Friedel-Crafts alkylation, we need a benzene ring, benzene molecule, we need chloroalkane, and also a catalyst, anhydrous AlCl3. The function of this AlCl3 is to generate an electrophile. Why does it, or how does it help in generation of electrolyte? This Al3 abstract the chlorine to become stable and have octet configuration. The aluminium is electron deficient, so it acts as Lewis acid. It abstracts the chlorine atom along with the electron pair and results in the generation of electrophile. That electrophile helps in carrying out of the reaction further. Now let's see some more examples. See, suppose this R could be methyl group or ethyl group. This is benzene ring. In presence of R, we take CH3Cl, so anhydrous AlCl3. This will result in methyl benzene, or also known as toluene. So you can see here an alkyl group has been added. Now we can see another example. Suppose instead of taking a methyl, we take an ethyl group. So anhydrous AlCl3, this will give us C2H5, that is ethyl benzene. Okay, ethyl benzene. So these are the two examples of Friedel-Crafts alkylation reaction. So now Friedel-Crafts alkylation reaction also have certain limitations. What are those limitations? You note down, then we will learn about it. So dear student, just now I have told you that Friedel-Crafts alkylation reaction also have certain limitations. So now let us concentrate on the limitations of Friedel-Crafts reaction. First thing, we can see here we have taken a haloalkane. In this reaction, Friedel-Crafts reaction can be carried out with haloalkane only haloalkane. We cannot take no vinyl halide or aryl halide. No vinyl halide or aryl halide. This will not react with benzene because the carbocation that will be formed, is unstable. Okay, so this is one limitation. The limitation is that whenever we are carrying out Friedel-Crafts alkylation, we have to take only haloalkane. We cannot take this vinyl halide or aryl halide. No. Second thing, second limitation, only certain alkyl benzene can be prepared. By this method. So this is the second. Now the question is why? This is because Friedel-Crafts reaction proceed via carbocation mechanism. Now if we try to introduce an alkyl group, these are the alkyl groups. If we try to introduce any alkyl group greater than 3 carbon atoms or greater than 2 carbon atoms, this is 1 carbon atom, this is 2 carbon atom. Suppose if you want to introduce 3 carbon atom in this, then what will happen? There will be rearrangement. There will be rearrangement by the carbocation, and we will not be able to introduce that particular alkyl group. For example, instead of if we want to introduce propyl group in the benzene reaction, benzene ring, if we want to introduce this same thing, then what will happen? We will not be able to do this. Instead, we will end up with this isopropyl group. So this is another limitation. Why? Because there will be carbocation rearrangement. This is due to carbocation rearrangement. You know that here primary carbocation will be formed, here also, but secondary, if it rearranges to secondary carbocation, then that will be more stable. So the desired product will not be obtained here. Now this occurs via hydride shift and methyl shift. So again I would revise it. First, for this type of carrying out this reaction, we are always required to take haloalkane, okay, only haloalkane. We cannot take vinyl halide or aryl halide. Second, we can only prepare certain, or we can only introduce certain alkyl groups here. Only alkyl group containing 1 and 2 carbon atoms. Whenever we are going to introduce 3 carbon atom, alkyl group containing 3 carbon atoms, there will be rearrangement, and hence this reaction will fail, and the rearrangement occurs because of the carbocation. So this is the second and second rearrangement, second limitation. Now also, this product, the product that we have obtained here, like in this example, we have got toluene. Now the product, whenever we are carrying out Friedel-Crafts alkylation, the product here, methyl benzene, if we take ethyl group, chloroethane, it will result in the formation of ethyl benzene. Now these methyl benzene or ethyl benzene, this methyl group or the ethyl group, they are electron donating in nature, As a result, what will happen? They will be more reactive, and hence what will happen? There will be more, the react products are more susceptible to electrophilic attack than what we began with. Again, I will repeat here, the product that we have obtained here, that is methyl benzene, this has a methyl group. Now this methyl group is what? It is electron donating in nature, so it will donate electron into the system, and as a result this product will be more susceptible to electrophilic attack than the what we have started with. So what happens? There will be polyalkylation. So this is another limitation. So basically we are having three limitations. First, we cannot take vinyl halide or aryl halide. Then this reaction fails if we try to introduce an alkyl group containing more than 2 carbon atoms. Third, the product itself are so much so much reactive that polyalkylation can occur. And one more thing, yes, which I was missing, is that if there is certain deactivating groups, presence of deactivating groups like NO2, cyanide, aldehyde, ketone, then ester, then acid, carboxylic acid, etc. In the presence of such deactivating groups, this reaction will fail due to compound limitation. So basically four limitations are there. Now you just go through it once more, and then I will write the limitations point wise. So just now I have discussed the limitation, and this is the gist of the limitation which I have discussed before. So only alkyl halide reacts, no vinyl or aryl halide. You please remember this reaction. We always have to take RCl, AlCl3 in anhydrous condition, and this will introduce the R group here. So here only alkyl halide. The reaction fails in the presence of deactivating group like NO2, CN, CHO. If there is some, say here NO2 group is there, it will not react. Okay, no reaction, because this is deactivating in nature. Polyalkylation can occur as the products are even more reactive than the starting material. Okay, so this alkyl, this is the product that is here, the alkyl benzene, the product will be more reactive than this. As a result, what will happen? There will be polyalkylation, so that will not serve our purpose of producing monoalkylated product. And finally, only certain alkyl benzene can be formed due to carbocation rearrangements. So we can produce only or we can introduce alkyl groups, these CH3 and C2H5. If you are trying to introduce C3 C3 plus 2 C3H7, it cannot be introduced because there will be carbocation rearrangement. So these are the limitations of Friedel-Crafts alkylation. You please note down, and then we will proceed towards Friedel-Crafts acylation reaction. I hope you have written this, so let me rub and continue with Friedel-Crafts acylation reaction. So the next topic is Friedel-Crafts acylation. So as the name suggests, what happens in this reaction? There is attachment of an acyl group in the benzene ring. So this is a benzene ring. If we attach anhydrous AlCl3 here, COR, then this is called acylation. This RCO group is called acyl group. Now this Friedel-Crafts acylation, it can also be called as alkylation. So don't get confused if you are asked what is Friedel-Crafts alkylation. Same as acylation. So let's see some example. For example, if we take benzene and an acid chloride like CH3COCl, this is known as ethanoyl chloride. In presence of anhydrous AlCl3, we will get what? We will get COCH3, that is acetophenone. So here we have got ketone, and so by this method we can produce ketone, or this can also be known as acetyl benzene. Another example is, instead of taking acid chloride, we can take acid anhydride, CH3CO whole twice O. Okay, in presence of anhydrous AlCl3, this will also result in the formation of same compound, that is, and there will be a side product, that is acetic acid, and it will be HCl. So these are the two reactions of Friedel-Crafts acylation, reaction 1 and reaction 2. Here we have used an acid chloride, and here we have used acid anhydride. Please remember, so whether we use acid chloride or acid anhydride, the benzene will react with them in presence of anhydrous AlCl3 and will give us the same product, that is acetophenone. But one difference is there. When we are taking acid chloride, the byproduct is HCl. When we are taking acid anhydride, the byproduct is acetic acid. So this is Friedel-Crafts acylation. Now, like the functions are same, anhydrous AlCl3, and this also proceeds through carbocation mechanism. This also have certain limitation. Let's see what those limitations are. So I'm rubbing this and writing the limitations. The limitations. First limitation is that only ketones can be formed. By this reaction. Second limitation is that, same as alkylation, deactivating groups, or the reaction fails in presence of deactivating groups. Reaction fails in presence of deactivating groups like NO2, CN Number 3, third is the catalyst AlCl3 forms salt forms complex rather to aryl amine, making them unreactive. Forms complexes with aryl amine, making them unreactive. So these are the three limitations of Friedel-Crafts acylation reactions. Okay, now I would give you two questions on this Friedel-Crafts alkylation and acylation, and you have to answer this in the comment section. The question is, I would write it rather here after rubbing. See, let me copy it down. The question 1: which of the following will not undergo rearrangement in Friedel-Crafts reaction? The options are A. chloromethane, B. This is another 1 2 3 4 5, that is chloropentane, C 1 2 3 4 chlorobutane, and D a product. You try to find out what could be the name of this product. And second question is question number 2: suggest an acyl chloride that was used to make the following compounds. Okay, I'm writing A. This is the product, Friedel-Crafts reaction product. So you have to tell which acyl chloride might have been used to produce this, and the second is something like this. So you have to answer these two questions, and write it in the comment section of the video. Now we will learn about some other reactions, other compounds rather, which also show Friedel-Crafts reaction. So what are those? Let's check out. So far, whatever we have learned was general information for every students of standard 11 and 12. Now there are certain specific reaction for grade 12 students, like what happens when Friedel-Crafts reaction of chlorobenzene and anisole is carried out, or sometimes it is also asked why aromatic carboxylic acids do not show Friedel-Crafts reaction, or why do anilines do not show Friedel-Crafts reaction. So in this section we are going to learn about that. So the first thing is the first part, that is chlorobenzene. We will take the example of chlorobenzene and try to find out what will be the product. So Friedel-Crafts reaction of chlorobenzene. Okay, this is chlorobenzene, all of us know this. First I am doing alkylation. So let's start with the chloroalkane, that is chloromethane, anhydrous AlCl3. We get here an important thing that you have to remember, we get a mixture of products, two products, because chlorine group shows resonance, and when we draw the resonance structure, we see that there is more electron density at the ortho and para position. So because of that, we get two products, one here the ortho product and another the para product. This is para product, this is ortho product. Now please remember, the para product is always the major product and ortho product is always the minor product. This is actually 1-chloro 4-methyl benzene. So this is the major product. Now you can ask question is why this is minor. Actually there is steric hindrance here, so that is not good. Now this was alkylation. Now if you want to carry out Friedel-Crafts acylation of chlorobenzene, so we take acetylene chloride or ethanoyl chloride. Here same catalyst, anhydrous AlCl3. By now you must be knowing its function. So again we will get mixture of two products, that is COCH3 plus COCH3. Again this is the ortho, so ortho product, that's why it is minor, and this is being para is the major product. Okay, so and what's the name? The name is 4-chloroacetophenone. This is 4-chloroacetophenone, and this one is 1-chloroacetophenone. So whenever you are carrying out Friedel-Crafts acylation or alkylation, this is alkylation and this is acylation. Whenever we are carrying out Friedel-Crafts alkylation or acylation of chlorobenzene, we get mixture of products. Please remember, mixture of products, one ortho product, one para product. Now ortho product is the major product. Why? Because in minor product there is steric hindrance. And why is it that we are getting two products? Actually this chlorine, it has lone pair of electrons here, so this is in resonance, and when we draw the resonating structure we see that there is more electron density at the ortho and para position, and it is the resonance effect which controls the reactivity of the reaction. So that's why we are getting two products, ortho and para, and out of them it is the para product which is found in major amount. Now we will see what will be the Friedel-Crafts reaction of anisole. So instead of chlorobenzene I will write anisole. Students, you must try to memorize names of certain or structure of certain product, like compound rather, like anisole, this is OCH3. I am carrying out Friedel-Crafts alkylation, this is CH3Cl, again anhydrous AlCl3. Again here we will get mixture of two products, CH3, this is CH3, this is the para, so, and this is the ortho. Again this is major. So the name of this product is what? Its name is 4-methoxytoluene. This is 4-methoxytoluene. So on alkylation we are getting this product. Now suppose if you want to carry out acylation of this reaction, So we will take acetyl group CH3COCl, same catalyst, anhydrous AlCl3. Again we will get mixture of two products, that is OCH3 and COCH3 plus OCH3 and here COCH3. This is ortho, this is para, this is major. And what is the name of this? The name of this compound is 4-methoxy acetophenone. So that's what we come to know about Friedel-Crafts reaction of chlorobenzene and anisole. Now in the limitation section I have told you that the presence of deactivating groups like carboxylic acid, sulfonic acid, aldehydes, esters, cyanides, nitro group, Friedel-Crafts reaction fails. So now one important question that is being asked is why aromatic carboxylic acids do not show Friedel-Crafts reactions. So let me write the question and also write the answer for you. It's very informative. I have tried to give you all information in one single video. See, the question is why aromatic carboxylic acids do not show Friedel-Crafts reaction. Okay, answer I'll write out here. This is because you already know by now the carboxyl group is deactivating I have written. You must be careful while writing the spelling deactivating, and the catalyst AlCl3, that is acting as Lewis acid. You must remember the catalyst gets bonded to the carbonyl group, so that's why it is not free and no possibility of generation of electrophile. Second question is also why aniline does not or do not show Friedel-Crafts reaction. Same answer. This is because this is due to the salt formation with AlCl3. Okay, as a result nitrogen of aniline acquires positive charge and acts as strong deactivating group. Okay, so the salt that is formed here, I would write the formula, something like this. Here I have written salt a salt like this is formed, and as a result you can see there is positive charge on the nitrogen atom, and hence what happens, the nitrogen atom, this because of this positive charge, it acts as a deactivating group. So these are two very important questions for examination point of view, be it board exam, be it any competitive exam. So we have come to the end of today's video. So let us once again recapitulate. We have learned what is a Friedel-Crafts reaction, what are the types of Friedel-Crafts reaction, what is its use, what are the limitations, and finally some questions like these two. So I would expect you go through this video once more. If you are not able to understand, we have to go through it again and again. So that's all for today. If you like the video, please press the like button and share the video, and also subscribe my channel. So until the next video, it's all the best from your Frank Guruji.